rules of integration. So basically, if we sort of almost doing the same sort of thing when we differentiated, so it's different sort of things that we did there. Okay, so we're just formally covering it. Alright, so when we integrate alright, so we're up to, so we're integral from b to a, okay, of f of x plus or minus g of x plus or minus, okay, alright. So basically all this is saying is that we can do the integral bit by bit, okay? So like we differentiated, we can differentiate bit by bit when we got the addition or subtraction between two terms, okay? So it's going to integral from b to a of f of x, notation dx, okay? That's important because that will tell you what you're integrating or differentiating with respect to, alright? Plus the integral from b to a of your g of x, plus or minus, sorry, plus a dx, plus or minus the integral from b to a of h of x dx, plus dot dot dot. Okay, so in other words, we can integrate each bit separately, okay, and then do substitute the limits in. Alright, second one. We're integrating from b to a of f of x, g of x, and so forth, so we're multiplying, okay, with respect to dx. Okay, what we need to do is we need to expand first, then use 1, okay? So use your chapter 2 stuff in your prelim course on your algebra skills, and expand that all out, and then apply that to up here.
So to expand it, you just times them together?
Like if you was a FOIL or something like that. Yeah. All that's saying is if we can't just integrate sort of this sort of property, we need to do something with this first before we do that. Alright, now this third one, this is going to come up a lot for you guys, so really thinking about this when it comes up and when I'm explaining it now. So, if you have the integral from b to a of some constant number n, okay, just a constant number, you know, 3, 10, million, pi, whatever, times f of x dx, okay, so instead of doing integration with that constant, we can rewrite that as n out the front of the integral from b to a of f of x dx, okay? And I'll show you more about that in a moment. But anything constant out the front, when you're multiplying, we can move that out the very front of the integral, and we include that out of the factor out the front of when we expand, okay? So we're n constant number. Okay, so in the same sense it works differentiation as well. When we're differentiating something with plus or minus in between, we can do bit by bit. Okay, and when we differentiate something with the product, we use the product rule. Something with the quotient, we use the quotient rule, and so forth.